Good morning, class. Here's elementary statistics practice test number 3, module 3, covering chapter 6 and 7. Here's chapter 7. Estimating parameters and determining sample sizes. Again, we start with the pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during the exam or any other exam for that matter. Unauthorized action include but are not limited to the use of notes, text, search engines, PowerPoints, AI, or any other resources not explicitly allowed. You may use formula sheet, tables, and a graphing calculator. So I want to answer the following questions: true or false? The confidence interval estimate of the population mean is constructed around the sample mean. Well, that's a true statement. And here's the way the confidence CI, short for confidence interval. It's X bar plus minus E. In other words, you start with the sample mean. Remember, normally we don't have access to population parameters. So we start with the sample statistic, in this case, X bar, and we make up an interval, and that is called a confidence interval. Sigma of X bar is sigma over square root of n. E is the alpha over 2 sigma over square root of n. Estimation means assigning values to a population parameter based on the value of a sample statistic. So we are interested in finding mu. We start with X bar. That's the idea. The confidence level is denoted by 1 minus alpha times 100%. The maximum error, also known as the margin of error, of the estimate for mu based on known sigma is the one that we wrote here, is the alpha over 2 sigma over square root of n. The parameter of a t distribution is only df, stands for degrees of freedom. Degrees of freedom. We're going to answer the following. What criteria are required to apply the t-distribution to make a confidence interval for mu? Number one, the sample must be a simple random sample. So it has to be randomly selected. Number two, either the sample is from a normally distributed population or n is large. How large? Larger than or equal to 30. Remember CLT, the central limit theorem. Population standard deviation, meaning sigma, is unknown. When sigma is missing, we use the t distribution. If it's given, we use the z distribution. So having said that, sample statistic is used as a point estimate, which is a specific numerical value estimate of a parameter. A point estimate is a single value or point used to approximate a population parameter. Example, the sample proportion p hat is the best point estimate of the population proportion p. Confidence interval. We can use a point estimate to construct a confidence interval estimate of the true value of a population parameter. That means we start with p hat and we make up an interval by going to the left and right of it using that margin of error, and every piece of formula is given to us. So t-score. This is the table, t distribution or critical t values. And we want to find the values for t, for a t distribution with a given sample size and a confidence interval. Looks like a normal distribution. As n gets larger, this becomes closer and closer to a normal distribution. And again, if you have two tails, The total area is alpha. You divide it by 2. In each tail, we have the alpha over 2. That's why if you are looking up the table, you have to pay attention to the left column. Gives us degrees of freedom. And then what about the rows? We have area in one tail, area in two tails. If area, for example, in one tail is 0.005, in two tails would be 2 times that. So 0.01. If the area in one tail is 0.01, in two tails is 2 times that, 0.02. So that's how you use the table. In the old tables, they just had the area in one tail. Now let's see how we read that. Find the value for t for a t distribution with sample size of 20 and a confidence level of 95%. Okay. So we are talking about confidence level. So you have to really draw what's in here is the accepted value, and what's in here is the tail where it gets denied. Okay. And so this has the confidence level of 95%. So this one, this area is considered 95%. So just to give you an idea of what's going on. And the tails obviously would be 5%. That means each one is half of that. Each one is 2.5%, just for the sake of argument. So the very first thing we need is degrees of freedom. Degrees of freedom is n minus 1. So here's the t distribution, the degrees of freedom, and as you can see, I have it up to 5. Then I move to larger numbers because of the limitation of the space. You can see the previous page and the entire table. So having said that, degrees of freedom is n minus 1. That means 20 minus 1 is 19. So in this column, the first thing you do, you look for number 19. So we find that. Then right across, you see a bunch of numbers. This one, this one, this one, this one, and this one. But if this is 95% here, that means 5% in two tails, 5% or 0.05 in two tails, or half of it, 0.025 in one tail. So we have this one. So 95% in the middle, the rest of it in the two tails. So putting these two together, this row and this column give us this number. And this is plus minus. Why is that? This one is negative of this value, negative 2.093, and this one is positive of the same value, plus minus 2.093. So that's pretty straightforward. Find the values for t, for a t distribution with sample size of 30 and a confidence level of 90%. Okay, so first, let me just explain something to you. Over here, this is 90% now, okay? Which means the two tails are at 10%, 1 minus that, or each tail is 0.05 or 5%. All right. Degrees of freedom, n minus 1, 30 minus 1 is 29. So in this column, we look for number 29. We locate that here. And then one of these numbers in front of it. Which one? Let's go back to this one. We said if this is 90%, the tails are 10%. So we look for 10% or 0.1 in two tails, or half of it in one tail. So now we're going to put these two together. And the answer is this one. Now, again, positive as well as negative. This one is negative 1.699. This one is positive 1.699. Now, you could use technology. For example, TI calculator, t-distribution and t-score. Second bars, inverse t, and you put two entries, left area and degrees of freedom. So if we want to go with this one, remember 10% in two tails, but this one needs just the left area. So if you put 10%, you're wrong. You have to put this, which is 0.05 degrees of freedom is 29. So 0.05 degrees of freedom is 29. And it gives you the left side, of course, with a lot more decimals. Okay. And then, of course, you should recognize for the right side, by symmetry, you make it positive. So there are two answers, negative as well as positive. You could use this t-distribution calculator online or critical t-value online, or you can use Excel t-distribution, find the t, score, t inverse, left area, and degrees of freedom similar to that. So depends on what you're dealing with. Find the critical chi-square value for 20 degrees of freedom when the area to the left is 0.01. The chi-square distribution must be used to calculate confidence intervals for variances and standard deviations. The chi-square variable is similar to the t variable in that its distribution is a family of curves based on the number of degrees of freedom. The symbol of chi-squared is a Greek letter chi, pronounced chi. A chi-square variable cannot be negative, and the distributions are skewed to the right. Skewed to the right. That's the shape. So take a look. Here's a portion of the graph of the table. On the left column, you see degrees of freedom. At top, alpha, and it's skewed to the right. And the shaded area is equal to alpha for chi-squared. And so we need two things. We need degrees of freedom and area to the right. So going to this question, degrees of freedom is given. You don't have to calculate it as n minus 1. And A sub L, area to the left, is given. Okay. So what we want the degrees of freedom, which is given, and we need the area to the right. If you look at this one, you must have an area to the right. And it's very easy to see that in this example, this area is given this much, 0.01, but we need this area, which is the complementary event, 1 minus that. So area to the right is 1 minus this number, which is 0.99. Okay, so now we have everything we need. Again, one more time, what do we need? We need degrees of freedom. So on the left column, we look for the degrees of freedom, which is 20. Because of the limitation of space, I add just one more row. This is what we need, 20. Okay, so, and then this is what we need for the row, 0.99. They come together, giving us 8.260. So we write chi-squared of the left side being 0.01 is the same as chi-squared of the right side being 0.9. And this is referring to the area. And the answer is 8.260. Bear in mind, all values are positive. It starts from 0 and it goes to infinity. Let me erase my one. So again, this is about reading the chi-squared table. In this case, degrees of freedom is not given, n is given. N is 30. And when the area to the right is 0.9, so degrees of freedom is 30 minus 1. Area to the right is 0.9. So again, a limitation of space, I'm going to have this one. So I need 29, and I need this area. So I'm going to put 29, okay, and 0.9 together. These two numbers. When I put them together, this results in this number. So chi-squared of the right side having the area of 0.9 is the same as chi-squared of the left side having the area of 0.1, and the answer is 19.768. So what we did so far, we looked at the z table, the t table, the chi-squared table. So that was about how to read it. Of course, we can use technology, but we should know how to use the tables. This is another calculator. You can find all of them in your syllabus or the module in Canvas. A statistician, now let's do some work. A statistician is interested in estimating at a 95% confidence level the mean number of houses sold per month by all real estate agents in a large city. It is known that the population standard deviation is 1.9. Okay. How large a sample should be taken so that the estimate is within 0.65 of the population? Okay. First and foremost, this is an application problem, a word problem. So what is given symbolically? We start with this one. This is confidence interval. So the confidence interval is 95%. This one is sigma equals 1.9. And this is E. So that's given symbolically. Now, here's the formula you find in your formula sheet. Confidence interval for the population mean is X bar, sample mean plus minus E. Sigma of X bar is sigma over X squared of N. E is Z alpha over 2 sigma over squared of N. And if you solve this for N, N becomes Z alpha over 2 sigma over E quantity squared. I hope everybody understands basic algebra. So we are going to use this formula. To use this formula, we need the sigma, we have it. We need the E, we have it. What about the Z? The Z, we don't have it, but it comes from the 95% confidence interval. So we draw, and we want a 95% confidence interval. This happened to be a common number. That means the tail is 5%. Each tail is half of that. So the total tail is 5%. 1 minus that. 2.5% in each tail, and the answer is positive 1.96 here, negative 1.96 here, okay? By the way, the tails are called the rejection region when we discuss the test of hypothesis. So having said that, now we got everything. Into this formula, we put everything that we got with the value of Z. So you put the positive value, although even if you put the negative, makes no difference because it's being raised to the power of 2. So put it in. And the calculator, always go with a couple of decimals. However, the methodology is this. This must be rounded up regardless. Why rounded up? In order to estimate that, we need 32.82, that is the sample size, pieces of data. That's the minimum amount. You must round up to 33. So even if this is 32.1, you must round up. Again, why is that? That means we need that many pieces of data for this to work. That means anything larger than that is even better. So, but we are looking for the minimum value. Let me erase my word. Find this 95% confidence interval if the mean for such sample size is 3.4. In other words, X bar plus minus E, X bar is given, X bar plus minus E, and E is 0.65, X bar is 3.4. So 3.4 minus 0.65, 3.4 plus 0.65, okay? So this is the confidence interval. Now, before I give you the meaning of that, I want to make sure you understand this is one way to write it, or (3.4) plus minus 0.65. Please understand, sometimes they want you to report it this way, sometimes they want you to report it this way, okay? So it's important to know how to write it. Which one do you write? The way they ask you, okay? It's important. So, okay, you got that. What does it mean? We are 95% confident that the true population mean is between 2.75 and 4.05. That's how you do the interpretation, everybody. A random sample of 20 female members of a health club showed that they spend on average 4.5 hours per week doing physical exercise with standard deviation of 0.75 hours. Assume the time spent on exercise for all female members is approximately normally distributed. What is the value of point estimate of the population? So let's write what is given. First of all, normally distribution. So it's ND, normal distribution. N is 20. And what is this? This is X bar. And what is this? This is S. It's important to understand why this is the case. It's a sample of 20. It's not a population. For those 20 female members, N equals 20, X bar is 4.5. And for the same group, standard deviation S is 0.75. Now, the reason they mention normally approximated, you can't assume that otherwise, because N is small and it has to be larger than 30 otherwise. If they don't mention that, you can't use normal distribution. So having said that, what is the point estimate? That means where would you begin for the population mean? You would begin with a sample mean. So point estimate of mu is X bar, which is 4.5 hours. Construct a 98% confidence interval for the mean time spent on physical exercise of all such females. What are the formulas? Again, formula sheet. X bar plus minus Z. Just before, for the Z, the same thing. Sx bar is S over square root of N instead of sigma of X bar. And is T alpha over 2 S over square root of N. So X bar, we have it. E is S over square root of N, can be calculated. And what's missing is T, and T comes from the choice of confidence interval. So 98% confidence interval, that means the total area in the tail is 2%, 0.02. So in other words, this area is 98%. Okay. So what is in the tail? Each tail is 0.01. So this is 0.01. Same thing here, 0.01, because this is 0.02. All right. N is 20, so we need degrees of freedom, which is N minus 1, or 19. And now You look up the table or you use technology to find the T is plus minus 2.539. Again, I've shown you how to look this up using the table. Also, we're going to discuss the technology in a moment. So we are going to write x plus minus e. That means x bar minus e, x bar plus e, mu is in between, and e is t alpha over 2 s over squared of it. So we need to calculate this. T is 2.539, S 0.79, and square root of n is 20. So that's why you write the given. It makes it very easy to take it from there. So you write this and you write it with a bunch of decimals. So x bar is 4.5. You're going to subtract this from it and you're going to add to it. So that would be the confidence interval. So we are this number, 98% confident that the true population mean is between these two numbers. That's the meaning of it. We are 98% confident. So having said that, if we want to use a TI calculator, we go to stat, tests, T interval, enter data, X bar, S, and confidence level. So we're going to put X bar is 4.5, S is 0.75, N is 20. They want you to put the value of N in this case. A confidence level is 0.98. Now calculate, gives you the answer. Okay, look at what they give us and what we have. The difference is this is more precise, everybody. Okay, we are using the table here. This one uses technology and more decimals. That's the difference. Out of 500 randomly selected adults, 300 said they were in favor of the death penalty for a person convicted of murder. What is the value of the point estimate of the population proportion? And first and foremost, what is given? Well, you're either for it or not, so that makes it a binomial distribution. We have 500 as n and 300 as x. The point estimate for p is p hat. P is the population proportion, p hat is the sample proportion, and the formula for p hat is lowercase x over lowercase n. So for p is uppercase x over uppercase n. That is the population. This is lowercase. So 300 over 500, 3 over 5 or 0.6. What is the 95% confidence interval for the population proportion? Remember, a binomial distribution gets estimated by normal distribution. So you should always go with the z because there's one approximation and you don't want to go with the second approximation with s. So always we use the z when it comes to binomial distribution approximated by normal distribution. So having said that, again, let me erase my work and give you the formulas erasing my work. So confidence interval is similar to the confidence interval for the mean was x bar plus minus e. This is p hat plus minus e. That's where we begin. Where mu of p hat is p, sigma of p hat is square root of pq over n. When we don't have that, we use square root of p hat q hat over n, and then e becomes e alpha over 2 square root of p hat q hat over n. So having said that, you want 95% confidence interval is e alpha over 2 square root of p hat q hat over n. So we have the p hat, obviously q hat is 1 minus that is 0.4. We have the n 500, we need to find the z. And z, we find it from the 95% confidence interval. So Q hat is 1 minus P hat. That's straightforward. When we go with this, obviously the middle portion is 95%. The tails are total of 5%, 2.5% on each side. It's a common value, 95% confidence interval. Just 1.96 is used here. So we're going to use 1.96, do the math, and we end up with 0.0429. P hat, which is 0.6, plus minus E, which is this number. Again, this is one way to write it. They may want you to write it this way, or simply put subtract and add this number, which means P is between the two, 0.5571 and 0.6429. So we are, let's just use the technology and the meaning of that in a moment. So confidence interval, one proportion, stat test, one proportion is interval, plug in the value. So X is 300, N is 500, confidence level of 95%. And look at these two numbers are the same. What does it mean? We are 95% confident that the true population proportion is between these two numbers. That's the meaning. How large a sample is needed to be 99% confident that the margin of error is 0.025 for percentage of golfers that are left-handed if we assume that 15% of the golfers are left-handed based on a previous study. So reminding you of the formulas we've had. Confidence interval P hat plus minus E. Sigma P hat square root of P hat Q hat over N. Square root. E is the same thing times Z alpha over 2. Now look at this one and solve for it. So you divide by this number, you square both sides, and then you get Z alpha over 2 quantity squared P hat Q hat over E squared. So what is given here? P hat is 0.15, confidence interval 99%, and E is 0.025. P hat is 0.15. So this formula has everything except now from 99%. And 99%, everybody, is also, so this is, so the total area in the tails is 1%. That means 0.005 in each tail. And that is a common value. So 99% in between. And those are the two values. So the Z is plus minus 2.575. It is also a common value, everybody. Let's plug in. Of course, Q hat is 1 minus P hat. So 15%, 1 minus that is 85%. Plug it into this calculator, this formula. You have everything. You have the Z, you have P hat, Q hat, E. Put them in. Now be very careful. This is sometimes what students make a mistake. They forget to square that and it messes everything up. Here's the number. And as I mentioned, this means we need minimum this many pieces of data. You have to round up, even if this is 52.1. So you go up to 1,353. So you must show this number and then your answer in your work. Assume that we have no prior information suggesting a possible value of the sample proportion. Okay. Over here, the assumption is we know 15%, but what if we don't have that? In that case, We go with the worst case scenario. We assume P hat is equal to Q hat equals 0.5. And by the way, when you do that, that gives you the largest N. If the value for N here is not larger than this one, we've made a mistake. So P hat equals Q hat is 0.5. That is the assumption. Confidence interval doesn't change, 99%, so the Z value doesn't change. Okay, and here's the E. So we plug into this one everything. By the way, P hat, Q hat, 0.5 times 0.5 is 0.25. Please understand that the product of these two means 0.5 times 0.5, which is 0.25. That's why. Okay, that's why sometimes they just use this formula. Plug in, evaluate, and here's what I mean. It doesn't matter what this is. You go up, you round up, always. You round up. The N is 2,653. Always round up. Now, again, notice this number is much larger than that. This is the most conservative estimate. Okay. Remember, if this many will do the job, any number larger than that is good. This is the minimum number we need for this one, just so you understand the difference. Given n is 30, x bar is 80.5, s is 4.6. They have given us symbolically. Assume normal population, find 98% confidence interval for the population variance and standard deviation. So practically everything is given. I want to tell you, these are the formulas you find in your formula sheet. So confidence interval for the variance, sigma squared, n minus 1 s squared over chi squared of the right quantity squared, the same thing over chi squared of the left quantity squared. For sigma, you really don't have to do any, just take a root, that's all. So we're going to work on the variance and then the standard deviation, we take a root. So having said that, what is given? So this is the shape, remember that. And in here, we put the 98%. So degrees of freedom is n minus 1, 29, 98% confidence interval, or 1 minus 0.90 is 0.02. So these two total is 0.02. So we have 0.01 in each tail, 0.98 in the middle. Okay. Now, in order to find the chi-squared, so these are the, so notice we have the n, we have the s, right? So we need chi-squared for the right and chi-squared for the left. What is the chi-squared for the right? You need two things. You need degrees of freedom, you have it, and you need the area to the right. Area to the right is 0.01. For this one, area to the left is 0.01. So you look for 29 degrees of freedom and 0.01, you bring them together, and that gives you the number 49.588. So we have this number. So practically we are done here. This one we want the left side. So area to the left is 0.01. So what is the area to the right? The entire thing, you can either add these two or say 1 minus 0.01, 99%. So now same 29 up here, look for this number, 0.99. Putting it together gives you 14.257. This is 14.257. So into this formula goes n, s, and those values. So n minus 1 is 29 for both of them. S is 4.6 for both of them. Now this one, chi-squared of the right takes this number, 49.588. And this one takes 14.25. You put it into a calculator. Sigma squared is that. By the way, normally they want the standard deviation. They may not even ask you for the variance. It doesn't matter. This is the process. You're not done. Now take a root. And how many decimals? However many they ask you. So we are 98% confident that the true Standard deviation is somewhere between these two numbers.